Okay, so this is progress update for I don't know what week. I'm not going to be doing those regularly, as you can imagine already by now. But I think every 4 or 5 years I'm going to be doing one. So it's I'm going to be just numbering them differently. But the progress log for this week is, or since I did a last progress update, is pretty it's pretty simple. So I'm still I'm heavily focused on the multiverse computing paper just because it has so many different things to play with inside that I'm just having a lot of fun. And I kind of like the way that it's kind of gotten me to explore tensor networks, to explore and to to explore D-Wave in the past couple of weeks, and to explore also VQE in a bit of a different way than I had done before, right? Like I'm actually really digging deep into the whole expectation value and why why these type of cost functions are differentiable and why we can calculate gradients at all. So this is what you probably can see this week. Like if you take a look at some of the videos. So I did a couple of long sessions on matrix product states and matrix product operators. This is tensor network stuff. And I'll go back to these, right? In the previous week I did about a bunch of D-Wave stuff, which I also have to go back to because I really didn't completely finish the whole thing. But I kind of wanted to move forward to VQE this week quickly, and VQE constraint. And so I got hooked into plotting. It's the third video already, plotting expectation values. So what I'm doing is I'm playing with VQE. I'm making small circuits with 1 or 2 parameters and then just plotting the expectation value. And I'm basically trying to see whether you can differentiate that and trying to see whether you can find the parent plateaus that people talk about, where you're like, okay, so you get to a point in your expectation value land where you cannot like move anywhere because you've basically converged somewhere, which is just like a local minima or something like that. And that's what I'm trying to play with. So basically, not like on the other side of things, I keep thinking a lot about like another way to represent quantum states, not just like having a system, having like the wave function that shows you, what the different states are at the system level, but like the 0, the 1, or like if you have 2 qubits, 0, 0, 1, or 1, 1, 1, 0, etc. But having a different way to represent a state where you have um, you keep track of the single qubit states, and then you keep track of entanglement between those states using hyper edges, so edges connecting more than one, two or more of those nodes. I promise I'll get on with the videos in this direction as soon as I'm done with the multiverse computing paper, but I'm just like it is so much to do with the multiverse paper that I think, and because those things really neatly come together really well. Kind of the thinking about the hyper edges for the entanglement together with the tensor network stuff. Um, and I think the variational part is something that I want. The VQE thing is something that I wanted to explore anyway because it's a direction that I definitely want to dig into as well in the coming months. So yeah, plenty of stuff to watch this week. Plenty of stuff to take a look at in this direction. So yeah, let me know. I hope you're enjoying the videos as much as I am. Yeah, I think that's it for the update. Basically, it's hardcore multiverse computing still. Just because it touches everything. It touches D-Wave system, it touches VQE, VQ constraint, it touches like tensor networks, it even touches classical stuff like classical optimizers, which I haven't really done yet. But um, yeah, basically, that's it. That's it really.